In section 2.5 now, we're going to be doing several more applications. It'll be a little bit more geometrical, and we'll be getting into formulas just a little bit more. So before we start, we're going to deal with a couple formulas. A formula is an equation in which variables are used to describe a relationship. So there's going to be two or more, not always, but usually going to be two or more variables, and it's going to describe the relationship between those two or more variables. So a good one that pops up a lot in real life is the relationship between Fahrenheit and Celsius. So the two formulas, technically it's just one formula rearranged. For converting between Fahrenheit and degrees Celsius is going to be, we have this first one, Fahrenheit equals 9/5 times Celsius plus 32. Or if we wanted to solve that for degrees Celsius, we have Celsius equals 5/9 times parentheses Fahrenheit minus 32. So obviously the C is Celsius and F is Fahrenheit. So let's do an example using those equations, which are formulas. So let's find the equivalent temperature in degrees Fahrenheit for 20 degrees Celsius. So we're trying to figure out what is 20 degrees Celsius in Fahrenheit. So that means we're going to be using the first formula because we're looking for Fahrenheit, and this one has Fahrenheit solved for. Okay, so we know that we have 20 degrees Celsius, so I'm going to plug that into C. I'm going to ignore the degree sign just for the sake of plugging it in. I'll bring it back after. So 9/5 times 20 plus 32. So 9/5 times 20. What I'm going to do is I'm going to do 20 divided by 5 first and make that 9 times 4. Because it was easier to work with. 9 times 4 is 36. So 36 plus 32, this gives us Fahrenheit is going to be 68. So that's 68 degrees Fahrenheit, obviously. Okay, so 20 degrees Celsius is the same thing as 68 degrees Fahrenheit. So let's do another one. This next one's actually pretty interesting. We want to know for what degree are degrees Fahrenheit and degrees Celsius equal to each other. So if you don't know this, it's pretty cool. There's actually a temperature where degrees Fahrenheit equals degrees Celsius. So let's figure out what it is. So I'm going to use that same one. You can use either one of those formulas. I'm going to use the first one. So I'm just going to write it down. So it's going to be Fahrenheit equals 9/5 Celsius plus 32. So we want to know when they're equal. So what that means is that we want to know when C equals F. So what that means is we can take that and plug that in. So we can either plug a C into F or an F into C. It does not matter at all. So I will plug in, which one do I want to plug in? It doesn't matter. I'll plug in the F into C. So instead of a C, there's an F. And now we're going to solve this for F. So it's a linear equation in one variable because there's only one variable now rather than two. So what we can do is we can subtract 9/5 F on both sides to get the variable on the left. Cancels over here. So I'm going to do this as side work. For the left-hand side of the equation, we get F minus 9/5 F. We need a common denominator. The common denominator will be 5. So for the first F, that becomes 5/5F minus 9/5F. So that's going to give us 5 minus 9, so negative 4/5 F. So that's on the left-hand side here. That equals 32. So we need to multiply both sides by the reciprocal of -4/5, which is -5/4. So looking pretty messy over here, but those cancel and we're pretty much done. So this is going to be F equals 32 times -5/4. So I'm going to use that trick that I was using before. 32 divided by 4 is 8. Times -5. So 8 times -5 is -40. So what that means is that 40 degrees Fahrenheit, -40 degrees Fahrenheit equals -40 degrees Celsius. So it's actually pretty cool. Okay, so let's do the next thing. So the next formula, that's another pretty commonly used formula, is the simple interest formula. So this is just going to be interest that's gained on a certain investment. So the formula used to determine the amount of interest, I. So the I here, capital I, is interest. Given a certain interest rate R and the principal P, so principal is essentially your investment or your down payment, over a certain amount of time T, is I equals PRT. So the interest equals the principal times the interest rate times time. So let's do an example. So we have to buy a new car, Mary borrowed $30,000 from a bank for 5 years. The bank charged an annual simple interest rate 4% for the loan. So this first question, we want to determine the amount of interest that Mary's charged by the bank for this loan. So we are obviously using the formula I equals P times R times T. So we're looking for we're looking for I, because we're looking for the interest. We're given everything else. We're given the principal. The principal is P, which is 30,000. I'm going to leave out the $sign. We're given that it's over a 5-year period, so T is 5. We're given the interest rate of 4%. So here's something you have to keep in mind. We need to convert that to a decimal. 4% as a decimal is 0.04. Make a little note. You always need these as decimals. Okay, so let's plug all these in. Now it's just plug and chug. So it's going to be I equals 30,000 times R, which is 5, times T, which is, oops, sorry, I just did it backwards, times R, which is 0.04, times T, which is 5. So we plug all that into a calculator, and you will get $6,000. So that's how much interest would be owned for a period of 5 years with a principal of $30,000 at an interest rate of 4%. Okay, and then the next question says, determine the total amount that Mary must pay back the bank when she repays the loan. So the total amount that's paid back, the total amount is going to be the principal plus the interest accrued. So the total amount here, the principal is the 30,000. We just found out that the interest was 6,000. So that means the total amount is going to be $36,000. So you borrow money, you're going to have to pay back more thanks to interest. Okay, let's do another commonly used formula. So the distance formula, or velocity formula. So the relationship between distance, velocity, and time. So here are all the variables defined for us. Distance is d, velocity, which is just a rate, is v, and time is t. So this relationship is velocity equals distance over time, v equals d over t, or we could solve that for d and make it d equals v times t. So we kind of already probably knew this, even if we didn't know the formula. If you think about our speed limits, for example, speed is in miles per hour for our speed limit signs. Miles is a unit of distance. Hour is a unit of time. So that's miles per hour. That's distance per time, or distance divided by time. Okay, so let's do an example here. So we have Matt Kenseth won a NASCAR race by driving at an average rate of 150.38 miles per hour for 2.66 hours. So we want to determine the distance of the race. Round the answer to the nearest mile. So let's write down what we have so far. We have the velocity, which is 150.38 miles per hour. I'm not even going to bother with units. You could throw units in there and see how they cancel off. I just like to leave them out. And we have time is 2.66. And we're looking for D. So since we're looking for D, we might as well use the version where it's already solved for, which would be D equals V times T. So we're just going to plug these in. So V here is 150.38. And T is 2.66. So we're going to multiply these together. And it says round to the nearest mile, so it looks like it's going to be 400 miles. So the race was 400 miles. Okay, so for the next thing that I have here, I have a lot of commonly used formulas for geometrical shapes. So we have two-dimensional shapes up here. So the top row is two-dimensional, and the bottom row is three-dimensional. So when we're dealing with formulas for two-dimensional shapes, we have area and perimeter. So that's the A and the P that you see for those formulas up there. And for the formulas for the three-dimensional shapes, we have volume, and we could also have surface area, which is not included here. Okay, so area is going to be squared units, and volume is going to be cubed units, and perimeter is just going to be one-dimensional. So you can glance at those if you want. We'll be using a couple in a second. Okay, so for this first example, let's find the value of the remaining variable in each formula. So we have A equals L times W. So this is going to be the area of a rectangle. Area equals length times width. So we're given the area, A is 64, and then we're given the length is 10. So let's plug those in. So we get 64 equals 10 times W, and we want to solve that for W. So we just have to divide both sides by 10. So that's going to give us W is 64 over 10. So I'm just going to write that as a decimal and actually compute it. That's going to be 6.4. Okay, and for the next one, we have the area of a trapezoid. So you can see that picture of the trapezoid on the right-hand side, and the area of a trapezoid is 1/2 times the height, and then in parentheses, one base plus the other base. So we're given the area, we're given one of the bases, and we're given the height. So that means we're solving for little b here, one of the other base. So let's plug everything in. So a is 210 equals 1/2 times the height. The height is 10. And that's going to be the base that we're looking for plus the other given base. Okay, so let's simplify this a little bit. So it's going to be 210 equals, so 1/2 times 10 is 10 divided by 2, which is 5. So this is 210 equals 5 times b plus 27. So what we can do here is we can actually just divide both sides by 5 right away. So that's going to be divided by 5, divided by 5. So it cancels over here. 210 divided by 5, that will give us 42. So 42 equals b plus 27. Lastly here, we're going to subtract 27 on both sides. What does that give us? 15. So we get little b equals 42 minus 27, which gives us 15. Okay, so let's do a couple other examples, a little bit different looking. So we're just going to be given a for one of the different variables with no numbers in it. So let's solve the formula A equals L times W. So that's area equals length times width. And we're going to solve that for W. So if we are starting with this, solving this for W, this is L times W. So to get W on its own, we have to divide by L. So we're going to get W equals A divided by L. Okay, for the next one, we have a perimeter of a rectangle formula. P equals 2L plus 2W. We're going to solve it for L. So 2L plus 2W. So solving this for L, we need to subtract 2W to both sides to get rid of it over there. So the left-hand side is going to be P minus 2W equals 2L. And then to get rid of that 2 multiplying the L, we have to divide it. So I'm going to write the L on the left-hand side again. So this is going to be P minus 2W over 2. Or another way we can write this, I'm going to write this a couple different ways here, just so we know they're all the same. We could write this as 1/2 times P minus 2W, right? So that means exactly the same thing. Or we can distribute that. If we distributed that 1/2, that's going to be 1/2 P minus, so we have 1/2 times 2, which is 1. So we're just left with the W. So we actually have all 3 of these different forms that all mean the same exact thing. So either one is 100% acceptable. Okay, next one, the area of a trapezoid formula. So we have the A equals 1/2 H times B plus B, and we're going to solve that for capital B. So for the first thing that we could do here, we can multiply both sides by 2, because we need to get rid of these two things. We can multiply both sides by 2 to cancel the 1/2. We can also divide both sides by H. So if we do that, if we multiply both sides by 2, that's going to end up giving us 2A equals H times B plus B. So I'm just going to skip writing the showing my work out for this one for now. Next, we can divide both sides by H. Then we're going to be left with B plus capital B And then we can drop the parentheses since that was the only thing over there. Okay, so all we have to do now is we need to get rid of that lowercase b. We can do that by subtracting it on both sides. So that's going to be capital B equals 2a over h minus b. So obviously I just wanted to kind of test you a little bit there. If you have to show your work for it and subtract the stuff off, that's fine. I just wanted to do one of them where I wasn't showing every little step. Okay, let's do the next one. So let's solve 2x minus y equals 7 for y. So this one could be a little bit easier here. So what I'm going to do first, I'll show my work for this one. What we can do here, we can subtract 2x to both sides. But what I'm going to do, I'm going to add y to both sides. The reason I'm doing that is because that's going to make it positive. So it's going to be 2x equals 7 plus y. Then we have to subtract 7 on both sides to get y by itself. And I'm going to write y on the left, so it's going to be y equals 2x minus 7. So a lot of times there's going to be more than just one way to go about doing this. So let's do a couple more here. Actually, just one more. So let's solve negative 3x plus 2y equals 6 for y. So negative 3x plus 2y equals 6. So we're solving this for y, so let's add 3x to both sides. So we get 2y equals 3x plus 6, or you could have written 6 plus 3x, it doesn't matter. And we just have to divide both sides by 2 to get rid of that 2 multiplying the y. Okay, so we're going to end up with y equals 3x plus 6 over 2. And I'm going to write this one a couple different ways again. This can also be written as 1/2 times 3x plus 6. Or we can distribute it and make it 3/2 x plus 6 over 2, which is 3. Okay, so once again, pretty similar to the one a couple examples ago. Those all mean the same exact thing. Okay, so that is it for this section.